gaur hemen daukaguna, nire eskubian, Jocelyn Burnell, horri bereari buruz ez dut egingo, zeren gehienok badakizute bera nordan, zer egin duen, arlo desberdinetan ez bakarri zientzien, baita ere zientziatik aparte. Eta nik nahi dudana da, zuek bera entzutea eta galderak egitea. Antolatu dugu, berak hitz egin ostean, ordu erdi batean, aukeratutako ikasle batzuk, talde gradu bakoitzetako bat, galdera bat egingo dio, eta gero denbora horren ostean zuek libre izango duzuten nahi dituzuten galderak egiteko, eta nahi ditut galderak entzun, galderak egitea, zen hori oso importante da. Vuelvo a decir, bienvenidos y bienvenidas a todos vosotros, es un placer ver la situación del Paraninfo como está actualmente, es decir, llena, es decir, que veo que el sentimiento que tenéis hacia la persona que está a mi derecha, Jocelyn Burnell, es muy importante porque ella es una persona, una buenísima científica, ha obtenido premios en ciencia muy grandes, pero no es únicamente científica. Llega a otros campos de la vida, vamos a decir, las mujeres refugiadas, las mujeres de minorías étnicas, etcétera, etcétera, problemas de feminismo, etcétera. Entonces, yo creo que esto puede ser un momento muy enriquecedor para vosotros y para nosotros, para todos nosotros, yo creo que para toda la sociedad. Por eso mañana a la tarde en la sala Vidibarrieta, a las 6:30 de la tarde, haremos también otro acto. Entonces, yo me gustaría que se hicieran preguntas. ¿Está ella dispuesta a responder a todas las que se haga? Como ella me decía, si es que sé cómo responder, es lo que me decía. Y al mismo tiempo, la metodología va a ser que ella hablará durante media hora y luego representantes de cada uno de los grados le hará una pregunta. Una vez que hagan ellos, daremos la oportunidad para que todos vosotros hagáis preguntas y, de hecho, sería muy importante que hicierais un buen número de preguntas. Orduan berriro ere eskarrik asko etortzeagatik eta hitza emango diot orain Jocelyn Burnell. So, is your turn. Okay.
Thank you for the welcome. Thank you for the kindness from the university, and thank you for being here today. I've been asked to talk about the value of science. I am a physicist, an astrophysicist, or if I want to be less scary, an astronomer, and that is my background, but my degree was in physics. And I will be talking about some physics topics today. If you do not do physics, please be calm. It will be okay. So, have you been to that place? You know that place? Some people are nodding. It's near here. Yeah. San Sebastian, along the coast near France. This is an aerial view. Let's see. Okay, I've learned how to work the clicker. So, right. I'm going to be talking about this bit of San Sebastian, not that. Beautiful beach, 2 headlands, and a little island in the middle. On the beach, there are some curious ridges. 1, 2, 3, 4, 5. And again, you can see here by the pattern of the wet sand, there are ridges on the beach. Curious. I have never seen that on a beach before. Have some of you been to San Sebastian Beach? Are the ridges still there? Do you know? Did you notice? No. Okay. So what makes ridges like this on a beach? Well, I think it's physics. So this is a picture from the air. This is land. This is a little rock. And these are the sea waves. And the sea waves go through this gap and they form these nice wave fronts. We call this diffraction in English. I don't know the Spanish word, but when waves go through a gap, they spread out like that. For physicists, I'm sure you will have seen this. If you have a wave coming along and there are two slits, like here, wave and two slits, then the way the wave goes through each slit is to make these semicircles and another set of semicircles for the other slit, and you get these directions where there is high intensity. So on a screen, you see bands of light and dark. So what has that to do with San Sebastian? Could this be sea waves going through two slits? There's the two promontories and an island. So there are two gaps, two slits for the waves to come in. Could the sea waves be behaving like this? And then on the beach, give us these bars. So does that make sense? We will try a calculation to see if it's crazy or sensible. So we need to know the separation of these bars. I think this might work better from this side. So we need to know what that distance is, or that distance, or that distance, or that distance. Well, there is a person here, which gives us scale. Except I think that is a child, because here you see the railings. They will be about 1 meter high. And this person is a bit bigger, but maybe not adult. But maybe these are 2-3 meters, something like that. So we can estimate the slit separation. We can estimate the pattern size as a few meters. From the map, go back, go back, go back, go back. From a map here, we can get the separation of the slits. Okay, from the map. And we can also get how far the slits are from the shore. And if you do all that, you estimate then that the wavelength of the sea waves is about 5 meters. So there's a wave, 5 meters, another wave, 5 meters, another wave, and that's okay. It's not very accurate, perhaps, but it's okay. So the theory, the idea that these ridges are because there are two gaps either side of the island, that seems to work. At least we have not disproved it. So I would say in this case the physics works. Another example. We go from Spain to Central America, to what is now Honduras, probably, maybe the border of Honduras. And in ancient times there, the people built these big pyramids. There are not many now that are full size. Most of them have fallen a bit. But I think this one has been rebuilt so as we know what it looks like. Here's a tree. Here is a fence post. That'll be about this height. And you see there are many steps up the sides of this kind of pyramid. The steps are important. So we're told that in many years ago, many times past, if the community was having trouble, maybe not enough food, maybe war, maybe sickness, the high priest, the very senior religious person, would lead all his people out, and they would go and stand here. The priest in front, all the people further back. And then the priest would clap his hands, only he had big hands, so it made a better note. That's better. And the priest would hear a sound come back from the pyramid. And he said, "It is the holy bird. It is the holy Quetzal bird. And it is speaking to me, the priest. And I must tell you, the people, what the holy bird says we must do. You must all pay the priest more. You must do this, you must do that. And if we obey the holy bird, it will all be okay." And I think the people believed him. What is the physics behind this? So we have a stepped pyramid, and we have a big man in his robes and his headdress going, and you listen. And there is an echo, but it is a special echo. If you make a clap, a short, sharp burst of sound, there are many, many different frequencies in that sound. If you want just one sound, one frequency, you need a sine wave that starts at infinity and goes on to infinity. If you stop the sine wave, you have a wave of this length, or actually twice this length. So if you stop a sine wave, it is no longer a pure frequency. The shorter you make it, the more complex it becomes. And that is very short and sharp and contains many frequencies. So the frequencies travel through the air and hit this pyramid. And I'm fortunate I have some steps here. I hope you can see most of the steps. So the sound comes along, and some bounces off the bottom step and goes back to the audience. Some bounces off this middle step and goes back to the audience. And some bounces off this step and goes back to the audience. The frequencies that go back most strongly are the ones that make this reflected wave and this reflected wave and this reflected wave be in sync. Their maxima line up, their minima line up. Those are the frequencies that come back most strongly to the audience. And to the Inca people from the pyramid, those are the frequencies that came back most strongly. So although this had many, many frequencies, what the priest heard back was just a selection of those frequencies. And which frequencies it was depends on the size of the steps on the pyramid. So suppose the steps have width d. Waves of wavelength d will reflect in phase waves of wavelength, 2D, 3D, 4D, and so on, will reflect in phase, and they will build on each other. They will not destroy each other. So the sound that comes back from that pyramid has lots of harmonics in it, and it's probably quite a pleasant sound. But it's not the Quetzal bird. It is just the priest's clap being reflected back. And the priest can interpret it as he wishes, like pay the priest more, and so on. So it was a bit of a con, to be honest, but as long as the priest is a clever man, it will work. Or as long as the priest is a physicist, it will work. Please use your physics properly, not improperly. So don't be cheated. Know your science. Thank you very much.
Jocelyn. Now is the term for the students, and now you have time just to ask any question you want. And now the first one that is going to ask is going to be Maya from biology. Please, you could ask the question you think is interesting too.
How has your experience been as a woman in the field of science?
As a woman in science, as a woman in physics, there are not many women in physics in Britain. I see a good number of women here, which is great. How many of the women here are doing physics? Good, excellent, thank you. When I was an undergraduate, we had a class of 50 with just one woman. And that was tough, because the guys would not work with me. Every time a woman entered the lecture theatre, all the guys would go and bang the desk and so on. It was not friendly. But I hope here it is better for everybody, and in particular I hope it's better for the women. But I have had to do a lot of my science on my own. There was nobody I could do homework with, because the guys would not work with a woman. But it gets better. If I had been in biology, not a problem. If I'd been in chemistry, yeah, okay. In physics, very few women did physics. Now, with astrophysics, there are many, many more women doing physics because of astronomy. Yeah, thank you.
Okay, thank you very much.
Now, John, from mathematics.
I would like to know how it feels to discover something, and what was your reaction when discovering the pulsar?
Thank you. I was a graduate student at the time, so I did not have much authority. I'm junior, not a big person. And first I had to convince my supervisor that this was something real, that it was not a mistake by the student, that it was not radio interference, that it was not the equipment misbehaving. But with time you go through all of those and you tick each one off. And finally your supervisor believes, which is great. And then it gets quite exciting. And it gets much better when I find a second one. If you just have one curious thing, yeah, maybe there's a fault with the equipment. When you have 2 and 3 and 4, this is something new. So that gets much better. So I hope you find many things, but I hope you find more than one.
Now from biotechnology, please.
Yeah,
How did you cope up with the failure during your career?
I always worked very hard. Of course, physics is quite tough. I think any science is quite tough. And sometimes you cannot do the homework, the assignment. You do your best. You put in what best you can, but you know you've failed to do it. And you just hope that somebody will help you. I was in quite a big class and we did not have much individual tuition. There was one interesting episode. I'm going to talk about gravitational radiation, which is pretty advanced. But in our final year, we had one professor and 3 students would meet for 1 hour a week. And we 3 students would say, look, we do not understand the solid state physics course. Let's ask for some help. So we go in and we ask for some help. And our tutor says, I don't understand solid state physics either. Let's talk about the Henry-Brown interferometer, or something like that. An advanced research topic. But he made it clear to us, and it was exciting because he made it clear, though we still had the problems with the solid state physics course. And I never got to understand solid state physics. Still don't. And stay very clear of it. Solid state physics there, I'm going here. But that tutor who would not help us with solid state physics went on to be one of the discoverers of gravitational radiation. A totally new kind of radiation discovered about 5 years ago, something like that. Maybe more. Yeah. So sometimes, things don't turn out as you expected, and in some ways they turn out a lot better.
Thank you.
David from biochemistry.
Yeah, do you think that today it's viable for any student or any person to make a career or a living from science?
Yeah, I think it's important we have as many scientists as we can. Actually, the economy in a country depends on science to a large amount, science and technology. And so I think the more people as possible should do science, and the greatest diversity of people. Because if you are in a minority, if you're not a white man, I'm sorry, but if you're not a white man doing physics, you are in a minority in Britain. And minority people bring in slightly different ideas, slightly different approaches, and that's what research needs. New directions, new approaches, new ideas.
Okay, thank you so much.
Thank you.
Aymar from chemical engineering.
Is it necessary to change the education system to improve science?
Sorry, I didn't catch that.
Yeah. Do you think that it is necessary to change the education system to improve science?
Sorry, I am not.
He wants to ask if it is needed to change the actual education system
yes.
just to improve
Right.
research.
Right, I understand. My apologies. Thank you. I don't know enough about the education system here, to be honest. I know the British system pretty well and the American system a little bit, because I have worked in both. But my knowledge of this system is through meeting researchers from Spain, Spanish astronomers, Spanish technologists, people like that. I think the main difficulty we all have is the pace of discovery gets faster and faster and faster. So there is a new discovery today, and tomorrow another, and the day after another, and another, and another. And you have to keep running to keep up. And that's, I think, the difficulty for all of us. maybe even more so for you because it will be going even faster when you finish university. Yeah.
Later from physicists, from physics.
Do you think that the future of the human being is outside of our planet?
If we make a mess of our planet, yes, but I hope we do not make a mess of our planet. We are finding many, many planets round other stars. Planets seem to be very common, and there aren't many of them like Earth, but there's huge numbers of these exoplanets, thousands now known. And it's become a big research area, so many, many more will be found. There is some talk of going to Mars, terraforming Mars. I think that is a one-way journey. I don't think you get back from Mars if you go to Mars, at least with the present technology. So I think it's probably more important to take care of this Earth, as well as doing research. But do not assume we can go somewhere else if we make a mess here. Do not make a mess here.
Eneko from electrical engineering.
So, I don't know what would you consider to be the most important thing for a scientist?
The most important thing for a scientist. You have to work quite hard, but you have to keep your brain engaged. Your brain cannot take a rest. So you have to be alert. I think it helps to be in a minority because you're working that little bit harder than the majority. But for everybody, ask questions. Is that right? Why is that like that? Do I understand? No, I don't understand. Why is that like that? And keep asking, keep poking, keep prodding until you understand. It's the things that you don't understand that will lead to breakthroughs. The things that you do understand, other people also understand. But the openings are the bits that you don't understand or haven't thought about before. Yeah.
Anne from chemistry.
I would like to know what has been the impact of your researching career in your private life.
What has been the
impact of your researching career in your private life? How has affected it?
It has affected, your success in the physics. How does it affect your private life?
Oh, my private life. Thank you. Okay. Disastrous. But one good thing, I think, I have a son who is a physicist. He is not an astronomer. He does solid state physics. Well, okay, he's my son. But it's very difficult, at least in Britain, getting better, but it's been very difficult for women, married women, to have careers. We moved many, many times when I was married. We moved for my husband's job. So I started in radio astronomy. I then went to gamma ray astronomy. I then went to X-ray astronomy. I then went to infrared and then millimeter wave astronomy. And each of these moves was because of my husband's job moves. And many times I did not have a glorious position. I was, but I got to play a part in X-ray astronomy, infrared astronomy, millimeter gamma ray radio. So I've had lots of fun, but not a lot of money and not a lot of prestige. Because still, I think in Britain, the man's career is seen as more important than a woman's career when you have a married couple. And it's often the woman who has to take care of the children. So you wake up in the morning and a little voice in the next bedroom says, "Mummy, I feel sick." and you know you're not going to work that day. Maybe you work from home, but you are not going to work. Husband goes to work, mother, no. So it's difficult being a woman in British society. Spain does rather better than Britain. At least for astronomers, I know. We have data on astronomers all around the world. It's from International Astronomical Union membership data. And the countries that have the most women astronomers, the highest fraction of astronomers that are female, are the Southern European countries like Spain, Italy. South America is also quite good. The countries that have the fewest, Japan, surprise, surprise, Britain, United States is not very good. The English-speaking countries are less good for women. The Latin countries are better. So you're in the right place. Thank you.
Bueno, eskerrik asko galdera egite, eta orain zuen txanda da. Osa, nahi dutenak esku behatxa eta emango zaizue mikrofonoa galdetzeko.
Do you have any advice for female students that want to do research to become scientists?
Yeah, if you can, I would suggest yes, do. It will probably not be well paid. It will be quite long hours of work, but to be in research is a great privilege because you are discovering new things. And that's always exciting. My particular research has been in physics, but I think the same applies in other sciences as well. So yes, if you can get to do research, I would suggest give it a go. Maybe you don't do it for the whole of your life, but at least do it for a bit. See how it is. Maybe you like it. Maybe you don't like it. Maybe you want another job afterwards, but give it a try if you can.
¿Otra pregunta? ¿Más preguntas?
Mm-hmm. When did I find out?
That you wanted to study physics.
That I wanted to study physics. As soon as we started doing physics in school. There is a story behind that. When I was young, 11, 12, we moved from first school to big school with many different subjects. The boys do science. The girls do cookery and needlework. I wanted to do science. My parents thought I should do science. My parents telephoned the head teacher. One of the doctors in the town had a daughter in my class. He telephoned the head teacher. And so did a third set of parents. And the second time the science class met, there were 3 girls and all the boys doing science. I think we were the first girls ever in that school to do science. The teacher made us sit right up against his desk because clearly we were dynamite. And the first term we did physics. It was great. It was easy. I came top of the class. One thing I got wrong. Here is a useful lesson. We were asked, what is the speed of light? In Britain, we worked in old units. So I wrote down 186,000 miles per second, which is the right answer. Then for the first time, I looked at that answer and I thought, that's very big, and changed miles per second to miles per hour. And so got it wrong. It's a very good idea to look at your answer. Is it reasonable? But don't do it for the first time in an exam. But I liked physics. I found it easy. I'm going to be a physicist. Thank
you. What encouraged you to persist in your career despite of being a woman full of men?
Yeah, it needed some persistence because society was not used to having women working as scientists. I just loved it. Astronomy is fantastic, so exciting, particularly at the moment in our lifetime. Many new pieces of equipment, many new discoveries, changing very fast. So I was lucky to work in many interesting areas of astronomy where there was lots of new stuff and lots of excitement. For example, at one time in my career, my child was about so big, I was working in X-ray astronomy. It was not a research job. I was on the technical staff, but I was looking after a satellite up there, an X-ray astronomy satellite. And the data from that satellite came across my desk for checking before it went to the scientists. And as it came across my desk, I say, yeah, that's okay. That's the source we're meant to be looking at. What's that? That source is not in the catalogue. Oh, it's a transient source. It's one that flares up and dies down again. So, Joe, here's your data. Professor, I need somebody to look after this data. Okay, send it to so-and-so. So there's, okay. A week later, I'm checking the data. Looks okay, looks good, settings okay. There's the source we're observing, that's a cluster of galaxies. What's that? That's not in the catalogue. That's the cluster, yeah. It's another new source, uncatalogued. Maybe transient, maybe flaring and dying. Okay. Graziella, here's the source of the data on your cluster of galaxies. Professor, I need somebody to look after that data. And it went on like that, time after time after time. And because I was where everything converged, I was seeing what was happening. I was right in the middle of it. But it was curious, these new things always happened on a Friday afternoon, and preferably the Friday afternoon of a holiday weekend. So lots of fun. That's what keeps you going.
What's your daily routine at work? Like you are always doing the same thing, or you go changing and seeing new things?
I now have a house with a garden around it, and I have learned how to take care of plants, flowers, shrubs, and I find that a very good contrast to using the brain in science. So I like that very much. For vacations, I usually go walking, hiking. It's shorter distances today because I have a hip, but my relaxation is to go walking, hiking. And I have been hiking in some parts of Spain, but not this part. So, yeah.
What motivated you to keep going in research while you weren't discovering nothing? Like, haven't you ever asked yourself, what if all my efforts are for nothing, or something similar?
I ask myself, what?
All my what if all my efforts are for nothing? Like if you discover anything, or
Right. What if my efforts are for nothing? Yes, it does happen. Sometimes you spend a long time working on something and you end up with X equals X. Nothing. So it happens. It's part of learning. You know you don't do that a second time. If you do it again, you are very stupid, but sometimes we do. It's part of life. We will all have failures of one sort or another during our life. Maybe our fault, maybe just bad luck, maybe things just go wrong. Maybe the car breaks down because you have not been taking care of it. Or maybe the car breaks down because somebody else goes clop into it. You learn what you can from these negative experiences and you carry on. Maybe next time I need to be a better car driver.
thank you.
What field of science would you have pursued if you hadn't become a physicist or an astronomer?
At university, we had to do many different subjects. Had to do maths, of course, physics, maths. I did a little bit of chemistry, 1 year of chemistry. I didn't like it. I'm sorry, but I didn't like it. I did 1 year of geology. Fantastic. Easy. I came top of the class without trying. Oh, maybe I should be a geologist. I go to see the professor who is head of department, and he says, no, not for women. I'm a woman. So I go back to physics and astrophysics. I discover later that professor is very old-fashioned. In another university, the professor would have said, good, come and do geology. But that's the way it works out. So I have appreciated the geology that I did learn in that class, because you can look at the scenery and you can say, oh yes, lava flow, or tectonic, or, you understand the scenery better if you have some geology. And as I walk along in the mountains, I'm looking at what there is on the ground. Usually quartz, which is pretty boring. But so interesting, yes. And how much you depend on your professors for guidance, and how impossible it is to tell if that professor is prejudiced. Only if you ask lots of professors will you see that that one is old-fashioned. But I couldn't do that. So, thank you. Nice question.
Where
are we?
Okay.
Do you think there will be a big breakthrough that will change physics anytime soon?
Oh, I don't know, to be honest. If I were working in mainstream physics, if I was a particle physicist or something like that, I could probably say, yes, we're going to discover whatever. I think there are a number of discoveries pending, nearly there in astronomy. For instance, at the South Pole, in the ice, a cubic kilometer of ice is serving as a detector for neutrinos from things out in space. And they have now, I think, 2 or 3 detections of neutrinos from outer space. And I think at least 2 of those detections are when a black hole is swallowing a star. Why that gives neutrinos? I don't know. I don't think anybody knows, but it's something to do with the way the star breaks up as it falls into the black hole. So there will be physics behind that, but it's not, so to speak, straight physics. It's physics disguised as astrophysics. Certainly, there are many more things to be discovered. And we've been saying this in each generation, because we solve something and we find another layer behind it that needs more discoveries and more discoveries. So there will be many discoveries in your lifetime, and they will be big surprises, and they will be fun.
Thank you.
Thank you. Just get a drink of water.
What do you think about, do you believe that more collaboration between university and private enterprises should be encouraged?
Thank you for that. Yes, I think that could be very useful for both the universities and the enterprises. At the moment, there is some, but often, at least in Britain, they tend to be separate communities. The only kind of crossover you see is maybe the industry gives some money for a prize or for a particular project that it wants done. But the interaction, there's not a lot, at least in Britain, and we could do with more. So yes, I think that's good. And if you can find a way to make that work, great.
Thank you.
Hi, I wanted to ask, how can we encourage little girls and kids from different backgrounds to do science and feel they belong here and they have this place and they deserve this as much as a white man?
Yeah. So really there are two separate questions there. How do you encourage girls as opposed to boys? And how do you get people from lots of backgrounds? To get people from lots of backgrounds, they have to see people like themselves being students, doing research. And so those of you who come from those backgrounds, there is an extra burden on you to explain to people like you that university is good. At least I hope you think university is good and research is good. We're doing quite well here for the number of women. I automatically monitor how many women there are in an audience. But let's try a show of hands. If you are in physics, would you put your hand up? And if you are a man, would you put your hand down? Yes. Thank you, ladies. Girls are still a minority in some subjects. And we have come to realize that this starts when they are very, very small. I don't know how it is here, but in Britain, you go into a shop selling toys. Pink toys, blue toys, dolls, cookers, cleaning, engineering, construction, leadership, battle. The gender is set the behavior of each gender is set very, very early in Britain. It's almost unconscious. And so now in Britain there is a campaign to let girls have toys like boys have. Construction toys, things like that. But it's uphill battle. And I would really like the advertisers, the toy manufacturers, I would like to go and make them change. But if people keep buying pretty pink dolls for the girls, and engines and construction kits for the boys, it's very hard to change society. But oh, it is needed so badly. How to make it work? I don't know, just keep the pressure. If you are interested, there is a website, English language website called Let Toys Be Toys, which highlights these gender issues. It's very much embedded.
Beste galderarik? Well, if there are not more questions, thank you very much, Jocelyn. It has been really a pleasure to hear you, and to answer all these questions.
Thank you very much. Thank you.
Thanks everyone for coming and for asking questions, and particularly you, the ones that you are in the first row, for preparing the question beforehand. Thank you very much. And just a clap to everyone.